What's up, everybody? In this tutorial, we're going to be going over how to create this energy shield, and we're going to set up functionality so that as your character steps on and off the platform, the energy shield will activate and then deactivate. And we'll be creating all of the assets needed to make these effects in this tutorial. So first, we'll jump into Substance Designer and create a nice procedural texture for the look and feel of all of the effects for our energy shield. Then we'll jump into Houdini and create all of the meshes needed for our energy shield system. And I'll go over some tips and techniques for how to make sure that your UVs stay consistent and scroll in the right direction each and every time we make our mesh assets. Then inside of Unreal, we'll go ahead and create all of our materials for our energy shield assets, and we'll add some extra layers of control so that we can modify the look and feel of our energy shield and customize it to our heart's desire. We'll add some particle systems inside of Niagara for that extra layer of visual polish as our energy shield activates and deactivates. And then we'll wrap up everything in our blueprint by adding our functionality to activate and deactivate our particle systems with animation parameters to animate our materials on our dome and our floor, as well as our lights. And by the end of it, you'll have this nice, awesome looking energy shield that you can customize as much as you want, set up with gameplay functionality. So let's jump right in and get started. All right, so let's jump into Substance Designer. And we're just going to create a nice procedural tiling texture here. So first thing I'm going to do is I'm just going to drop down a shape, and I'm going to use a disk pattern with a slightly smaller scale. I'll then send it into a shape splatter node here into the input and use that pattern input as our base. And then I'm going to slightly change the scale, the randomization of the scale, and give it a little bit of a random position. And then I'm also going to change kind of the height offset so it gives a little bit more depth to the texture there. And then I'm going to send it through a levels node and just kind of crunch that down so we just boost those white values. And then this is something I'm going to use quite a bit. So I'm going to send it into a slope blur grayscale. I'm going to invert it first, send it through a blur HQ grayscale. The quality and intensity there, 3.99 for intensity. And then I'm going to send it into a slope blur grayscale and just crank the samples up and intensity to around 3.51. Send it into a directional warp and just send that intensity a little higher to 24.46 with a Perlin noise, the scale of 12, and disorder somewhere around 0.91. And then I just copy and pasted the slope blur. So it's very similar. The intensity is a little bit higher there, but then the blur is still around 3.99. And then I'm going to send it into a bevel. I'm going to kind of define the edges a little bit more. So that's where our eventual breakaway or borders will be for where our erosion ends. And then I'm going to invert that back and again send it through a slope blur grayscale. And this is starting to kind of define the overall shape. Intensity at 5.6 this time on the grayscale, and same intensity for the blur. Then I'm going to send it through. I'm just going to copy and paste the shape splatter. I'm going to change the pattern amount, and I am going to still use kind of a scale, different randomization, change some of those settings, the position, and then the height offset again to kind of get the randomization. But this is just going to be kind of a secondary texture used to kind of cut further into our texture. Again, with the levels to boost the values, send it through a blur HQ grayscale, 3.09 intensity into a warp. And that warp will be about 0.8 in the intensity with a Perlin noise that is scaled to about 9, 0.36 in the disorder. Running it into a slope blur again. This time the intensity is pretty low, so around 0.33. And we've inverted it. Going into another warp node here. Intensity around 0.89 with the Perlin noise. And the scale around 15 and the disorder around 0.36. And so you can see a lot of this is very similar. I'm using a lot of the same techniques to just continue to kind of find the shape of this texture. Sending it into a blur again, and that intensity is around 2.37, and then I'm just blending those two together with a max lighten. And that's kind of giving me this nice erratic shape pattern here. So a goal is eventually to get to something very organic looking. So following the same pattern as we have, I'm just inverting it. Blur HQ grayscale, same values as earlier, as 3.99. Slope blur around 5.6. I'm always cranking the samples and quality as high as they will go on these blurs. Perlin noise set to 13 on the scale, disorder of 0.36. And then this time I'm going to go into a multi-warp grayscale because I want to get kind of multiple directions that this texture is going in. That'll give it a little bit more breakup and make it a little more organic feeling. And then I'm just kind of changing the angle there. I've got it on min on the mode and just changing my intensity to around 33.83, sending that into another blur at 2.9. And then I'm using that blur to drive the directional warp. So it's going into the directional warp, and you can see that's where we really get that shape pattern now. Now it's really defined those edges, and we have kind of our organic looking noise. And then I'm running it in here. You can do this, I think, on any node. I like to do it on just a transform node, but I'm not using this to transform anything. I'm using this to set the color output. If I were to leave this at 16, if I were to try to crunch it down to 16 bits, you can see it's at 32 floating, which is going to make this texture size very sizable. Even at 16, we're probably around 4 megabytes, which when texture memory is an issue, you want to have your textures nice and low in memory to start out. So I'm taking this to an 8-bit per channel texture. So I'm just using absolute, and it'll automatically give me the 8 bits. I can also choose if I want different color spaces there. So we're going down to 8 bits. We don't really need the extra from a 16-bit texture, so this will be fine. And then I'm just using a histogram range, just changing the position to see that it finds some darker values, and then I'm just kind of brightening up everything through the levels node again. And that is giving me kind of all the variation in this texture, and then sending it through an output. Just name it what you'd like. Here I've named it noise 3. You can add kind of your usage. I'm just doing RGB. You could do mask here or kind of whatever, set it to whatever you want. Diffuse is fine for this, and then I'm going to set it to sRGB. And then we're just going to export our texture. By coming up here, we can save it and right click on here and export output as bitmaps. There's usually a graph portion here I delete just so my identifier is the only thing that I care about. And that will give me the exact noise of my texture. Find your location. And if this, sometimes even defining it as sRGB in your node, your output node, doesn't always work, and it ends up coming up as raw. So just make sure this says sRGB when you export, and go ahead and export your texture. All right, so we're going to move into Houdini now and create our meshes for our shield effects. And the first one we're going to do is the dome. And we are going to drop down a line at the very beginning of this pipeline. Just give it a slightly longer length. And then I'm going to drop down a labs cylinder generator. And I like these lab nodes because they give you extra options like adding vertex color in case you want to use that for a mask, or adding noise, things like that. And then what I'm going to do next, so don't mind how this looks. This would just look like, if I were to drop this down real quick, lab cylinder, this would just be a straight cylinder and that curve wouldn't be there. And this is how that would look normally. But what I'm going to do is I want this cylinder to take on the shape of a sphere. So I'm going to drop down a sphere. And the reason why I'm not using the sphere generator as my final mesh is because you really have to fight with the UVs. They don't naturally go in the Y direction like I want them to. So I would have to really fight with a UV texture to make that happen. So instead, I've always kind of done this shrink wrapping like technique to shape cylinder meshes to kind of a different mesh that I want. So if it's not a sphere or it's something else, you can still have those scrolling UVs in the X and Y direction, but you can shape it to a different mesh based on your needs. So I'm just going to transform. I'm going to look at my cylinder and I'm going to transform this up to the size roughly of where my cylinder is. And kill that. And then I'm going to then come back to my cylinder and look at this mesh and use my ramp to kind of shape my cylinder close to that sphere, which is kind of what I did here. We just want it close to the edge as possible of this sphere, and you give it enough points so that you can make it snap a little bit easier. And then we're going to drop down a ray node. In this ray node, we're going to transform our points through the minimum distance to our sphere. So you drop your cylinder in input 1 and your sphere in input 2, and we're just going to snap it. And so now it takes on that perfect looking sphere. And so then we're just going to transform this up so that the scale works in Unreal. Now you can go straight to 100, and I recommend usually using 100. I changed some things along the way, and so I have a slightly smaller scale just to make it work for me. So for this tutorial, I recommend sticking with my units here, but in any case when you use this, you could just use it as 100 and then change that in Unreal. All right, then we're going to use an ROP FBX output, and we are just going to save the current frame and just give it a name, save it to our HIP file, and save to disk. Now, one thing I didn't mention, these are checks along the way. So if I come back here, I'm just seeing how my UVs go here are going to transform. So if I scale them down, if I transform them, I can see that they're going in that X and Y direction perfectly. So that's why I have a transform there. The material node is, again, it's just a check. I like to come over here to the settings, go to materials, drop down a natural one with wood chips because it has an image texture on it with displacement, and drop that in my material slot here. And then I can check as I scroll my UVs how this displacement looks as my mesh, is kind of scrolling, and how it will work with the texel density of the mesh itself. So again, that's just a check. It's not necessary, and it's not something you're going to export out in the information. All right, so let's move on to our floor mesh. This is going to be a lot simpler. We're simply going to start off with our line again. Now, this was up quite a bit for our cylinder, but I gave it a very low value so that because if you go all the way down to 0, it gets rid of your grid. You can see as I snap it. And so just for a sanity check, don't think it really matters, but just for a sanity check, I just do a very low value. So you can see it, 5 zeros and a 1, and that keeps our grid there and still makes it flat. And so that's my line dropped into a cylinder generator. So that was you seeing kind of the end result. And the way I'm getting those snapped vertices to the top, I'm just pulling them down so that they snap in like we did with our sphere. So it's going all the way to the bottom and giving us this disk mesh. And you can see that this cylinder has the same settings as the one we just did for the dome, which then if we go to our UV transform, we will see that our UVs are correct. And they're going to be scrolling the way we want. You can do the material check again. Again, it's not necessary. And then I'm going to just transform this up. Again, this could just go to 100, but I am just going to use a value of 95.6 for this tutorial and then save it out. And then finally, our energy shield particle itself. These are going to be quite small. Again, we're using a line with a length of 0.45. I am using 9 points because I want it to have rows. So that's giving it the rows, because if you send it into this sweep node here, it will give it columns. And so the way you get the rows is through the points, and the way you get the columns is through the sweep node. And I'm using a ribbon with the quadrilaterals, and then I'm just increasing the width just so it's not as rectangular. So I just have increased it slightly. I think that's all I'm changing there. Other than that, I did an edit on it. And what's great about this edit node So I added this. I didn't just start editing the points. I dropped it down so that I could go to this soft setting. And what I'm doing is I'm making sure points are active. I select my point, and this soft setting gives me a value that allows me to translate all the vertices attached. You could pull it out further, but I am kind of giving it this kind of edge with just a bump out in the middle. So as you pull out your vertices, you can see that it's only going to affect the area with that kind of fall off radius on it. So that's a great part of that edit node that I really like. And then the last thing I did was I just transformed it. I just moved the centroid to origin, made sure it was in the center because these are going to be rotating later on. And then I just gave it a scale of 22.7. I want these to be kind of small, and then just save those as well and give them a name. And those are our meshes. All right, so let's quickly go over importing our assets into this project. So first, let's just go ahead and import our meshes. So under the tutorial folder, under assets, I have my meshes here. And if I were going to insert these, let me just go to up a level so that I don't override what I did already. So for settings, I always choose replace the vertex color in case at a later time I decide to actually use vertex color for masking purposes. I do not want to create any materials, and I don't want to import the textures since there aren't any. So we're just going to just hit import all. So I would just highlight all these, drag them all in, hit import all, and that will import your meshes. And then as far as our textures go, once you drag this in here, we can go into the settings, and sometimes in production, these textures can be a little bit extreme for texture budgets that are in use. So you can just scale it down here, and you can see the resource size will change. It's part of the reason why I use 8-bit textures, just to keep texture size down. And then you can just come down to the level of detail, and under the texture group, just set that to effects so the system recognizes it as in a texture that will be used for effect systems. All right, so we're going to jump into our first material, which is our energy base. And it looks quite complex, but really it's just a matter of adding a bunch onto it as you build it out. And I'll kind of show you some of the tricks that I've used. All of our materials are going to be translucent, unlit, and two-sided. And so for our first part on our energy base, we are going to set up our distortion. And you will notice that I use this setup, actually all of this, a lot. So these are going to be duplicated. You'll see that these parameters are all kind of duplicated throughout multiple uses in this shader. So once you build out one, you can kind of copy and paste. The only thing with Unreal now is when you copy and paste, the parameter does not change. So make sure you rename it before you start adjusting your values. Otherwise, you will adjust the values of all of the parameters with the same name, and you'll have to go back and try to figure out what you did. So I'm just setting up my UV coordinates. I am appending a vector. I'm just setting up an append vector with two scalar parameters that I'm calling X and Y so that I can have kind of an uneven tiling of the texture if I want. And then I also love to add another multiply and set up another scalar parameter as kind of a master scale. So once I've gotten the look I want here, even if it's 1 and 1, I can still scale this up by 5 without having to come into the individual values later on. So I like to set up the scalar parameters, just gives me more flexibility. I like setting them up like that. Then setting them into a panner. Just make sure on your panner nodes that you set them to fractional part. Doesn't make a huge difference, but it kind of keeps it within a range so that it doesn't degrade over time. Every now and then that makes a little bit of a difference. So I like to keep it on the fractional part just in case, and then set up another append vector with X and Y speeds. So I can kind of control my speed directions. Now this is something I like to do. A lot of people will just stick with a texture sample and convert it to a parameter so that you can have your texture parameter there, but I like to throw it into a texture object parameter. So if you type that in, texture object parameter, and that allows me to string this together in multiple texture samples, or some material functions will only take a texture 2D. And so it just makes it easy for me to kind of keep it a little bit cleaner as I'm moving through my graphs. So that is what I'm going to use, and we're only going to use this one texture for all of our materials. So that will be our parameter that's set up. I'm going to run it through this component mask. You do not need to do the R channel. You can run it through the RGB channel, and it will do the same thing. I was just trying something, I think, initially, so don't worry about the fact that if you're going to run it through that channel. This is just separating out the red and the green channel so that we can use it to distort our UVs. Now you can also use a normal map for this, and you can do the same thing where you take the normal map and you just steal the red and green channels and leave out the blue channel, and that will distort your UVs in a different way. So these are two methods of distortion. I use this approach a lot because I end up kind of getting what I want from it, and I usually end up using the same texture that I use for my noise, or things like that. So I'm going to send it into a multiply and then create a scalar parameter, which is going to allow us to increase and decrease the distortion amount. So you can see if I set this to 0 here and go to my generated band, you can see that it's not doing anything. And then if I just set my value back, you can see that we're getting quite a dramatic distortion in that band. So moving off of our distortion, we're using the same distortion for both our radar scan, which I'll explain in a second, and our noise. So our noise is the main texture we're using to drive all these values. These are my scale. I copy and pasted, so you can just copy and paste the values from the distortion. Just make sure you change the names. Another thing to note is I'm setting up all of these in groups, and I'm putting a comment box around all of them so that I can keep them organized. So these are all my noise parameters, and everything in noise is getting a group with noise so that it's easy to kind of pick those out later. I'm then sending the noise into an add, and I'm using a Fresnel to kind of give a glowing edge around the dome. And so I'm just adding that value to the overall look. So I have that glow, and you can see the Fresnel is giving it kind of a glowing edge around the outside. So that's being added to our noise, which is then going into kind of an erosion. I'm just using a smooth step. There's two different smooth steps you can use. One deals with an alpha and one deals with a value. It's very similar. This is the other one, and you'll see there's an alpha, and you would set them up the same way. So if you wanted to drive this from just an alpha map, you can do that. But I'm driving this through the value of what I'm getting here. So this is my erosion. I'm setting up an erosion amount and then the max value. You can also call this erosion softness if you want, because that's basically what it's doing. If you were to just use erosion amount and turn this down to 0, you'd get a very hard edge kind of cut in your erosion, which you could also use a value step for if that's all you want to use. But the erosion max value down here allows us to soften up how that erosion is used. And so it kind of gives us softer transition out in our erosion values. So I am just throwing that through to the opacity and adding a depth fade. And this is the distance I have set up for that. You can usually keep that around 25 and play with that in your material instance. This is just so that if the mesh is close to touching the floor, we'll have a nice soft fade off of the edges of our mesh rather than cutting through another mesh. And then I'm just adding a fade on the opacity. So I have it set quite low here, but if I were to set that to 0, you would see all of this disappear, just because that is what is controlling kind of our master opacity here. So what am I combining with this? I have a procedural grid kind of set up from generated band, and all I've done is I've taken 2 generated bands. I have flipped one of them in the direction so that it kind of gives a crosshatch pattern. So if we kind of preview that, you can see there's a very, very tight crosshatch pattern going on. And that's because my pattern is very high. I have it set to 512 in the scale. And you can move that, you can change that to get different looks. I have grid sharpness and grid width set up. And then I also have a power connected to this. And I usually like connecting powers at the end just to control how much of a, let's see, oh yeah, it's because I am not previewing it. Let me preview from here. So you can see how it's kind of eroding away, from that texture. Let me get back to the values I had. Just minus 0.75. And there we go. So you can see our grid. I'm then feeding that into, before it goes into the color, I'm feeding that into another generated band that I'm calling a radar scan, which is just this red band going around the outside of our dome in the X direction. And that's just giving us kind of a look as if this shield has some life. Like if there were incoming missiles, then this would detect it and keep us safe. So I have set up a panner and I'm just scanning in the X direction, or I'm just panning in the X direction, just a value of 0.5. My generated band, I have switched the direction so it is vertical instead of horizontal and giving it a very low, narrow value. And I also set up an add because I am distorting the UVs as I showed you before. So we're just adding to the UV coordinates to distort those. I'm throwing a time into a sine, which is just giving us kind of an on and off, just a 0 to 1 blink. And that is turning on and off our generated band. And that's why I sent the grid through it, because I wanted to carry on with the look of our energy shield, and again gave it a power just so I had more control over how strong this band is. And then we're just using that to feed into our alpha. So this color will be blue for the most part, but everywhere this energy band is, because we're basically using this sine value from 0 to 1, when it hits 1, it is turning on our energy band or our energy radar scan. And we're using that as kind of the alpha to drive this from 0 to 1. So once it reaches 1, it's going into our orange color. You can see what that is. And if it's off, it's allowing us to just have our blue color, which is why the whole shield looks blue at that point. And that is just set to 250 in that blue color. So for the most part, everything will be blue. We're also sending the grid pattern through our emissive color. And that is allowing us to just show up on our emission and not our opacity. So then once that lerp goes through a multiply, because it's going through our Fresnel mask, and we are also sending it through our radial beam, which has a radial beam distortion, and I'll show you that in a second. And then all of that is multiplied by our band. It's going into emissive color. So now we'll go to our opacity. We have a radial beam distortion. Again, these are just the copied values that I showed you before. You can see what I've changed going through our distortion amount. So this is our radial beam distortion amount, which is then, again, copied parameters, same setup as before, running into an add to distort our UVs and running those through the UV coordinates of this band. And there's just a horizontal band that is shifting down our energy shield. And so I have these settings for the beam width. And then I also have kind of this kind of works in the opposite direction of the power. This is kind of going to be the intensity of our beam that's shifting. And then I have a radial beam mask on here. And I'm just taking UV coordinates, using a component mask in the green channel, sending it through a 1- and multiplying those two results so that we have a fall off on the top and bottom, and then giving it even more of a fall off overall, controlled by a power, and then just multiplying that by the beam result so that it's not going through the top and kind of falls off on the Y values there, or the Y coordinates. And then we're just multiplying that by both our emission, or sorry, we're adding that to our emissive values and our opacity overall. And then the final thing that I'm multiplying into our opacity is the warp energy, which you will see later. And that is just another mask that is going to go from either bottom to top or top to bottom and allow us to activate the shield in the direction that we want. So it will expose all of the underlying noise in the direction that we want it to go. So again, texture coordinate going into a component mask. And we can switch the direction. So instead of me multiplying this, I want it to go in one direction or the other. So if it's negative, I've set up a static switch parameter here that will say if this is activated, then it'll go in the negative direction. we're sending it through a power, and that's the warp energy power. And you'll see that value played out later. And then I am also doing a negative, a 1 minus on there to add kind of a mask to the bottom edge of our warp power. So I just multiply those two together, and then I'm setting that into the multiply. And again, this whole mask right here will activate our energy. It will expose our values from bottom to top. And then there's just a very simple world position offset. There's no noise texture going into this or any other factor. It's just going into a straight multiply by 1, and I'm setting it quite high. And you can just see, if I'll show the material instances later, but if you were to look at what is going on, if I go down to this world position offset, I've set it to 12. If I set it to 15 like it is now, you'll see it increases our sphere. So I'm using that just as a little extra control. So if I wanted it to pulse out or do some extra things, I have that ability through that world position offset value. All right, so let's move into our energy distortion. We'll set up our distortion. So these are the same, this is the same setup we used before. So you can copy and paste this. The only difference is I'm adding a multiply in between our speed for our panner, because I want to have a universal speed multiplier, which is what I've set up here. And if we were going to throw this into a particle system, I also have it as a dynamic parameter that I have set up with a static switch parameter. And the reason why this is a different color is because it is used in multiple places in case I wanted to activate this as a particle system. I'm going to ignore these setups, so don't mind them. We're not going to use it as particle system. It's just there for functionality in case it's needed. Sometimes I like to build things out that way to have more use cases. So our speed multiplier is feeding into this chromatic energy speed up here, our distortion speed, our mask distortion, our refraction normal, and our world position offset. So that is probably all I'm going to mention about that, but the reason why I do that is because I can have speeds calculated and balanced per each section. And then if I decided I wanted to increase the speed, I don't want to have to go through all those parameters again, especially if they're balanced and they're all functioning the way I want them to. I would rather just increase the speed and decrease the speed with one parameter universally, and it makes it easier. So that's why I've multiplied the speed by that parameter. So our distortion up here is very similar. I have a very low distortion amount this time. That is going into our chromatic energy distortion, which I'll explain in a moment. Then I have a mask distortion. So this is going to distort our mask that we will set up. Again, same setup and carbon copy from the top. We have a mask distortion amount of the same value, 0.05. And then these are actually the UVs that are going into our generated band. I just have pulled them down to the distortion mask. So I'm adding to our UVs. And that is our distortion. So you should have a material function called chromatic aberration that I've created. It is not native to Unreal, but it should be in the project file. I'm not going to go into the details of how this works, but basically you're going to hook up your texture. You have a chromatic shift amount, which is going to determine how much RGB shift you see. So if I go to 0, you'll see there's none. We're going to give it a value of 5 so we see it. And then the texture power is the overall noise texture that you are adding. So if I were just to increase this to something huge, you would notice it just goes away. So we want it kind of low. And then we also have a tile and a scroll, and we're setting it up like we've been setting up the rest of our material shaders with those append vector values. And then there's a desaturation amount, which actually the more you go in the negative value, the stronger the saturation is on the chromatic intensity. So we're at -6. And then you can also have, you can boost that chromatic intensity from this value. So if you want it to be stronger, more pronounced, you can use it here. The time is the value that is going into scroll our UVs. So that's just allowing us to scroll it. And that is our scroll speed. So the chromatic intensity will have a noise texture that we can also add color to later, which is how we're going to get the banding on the energy shield. But if you wanted just the chromatic intensity, or you just wanted just the chromatic shift, you can set the color that we are setting up in this color value to kind of a gray, a very dull gray. And then we have an emissive intensity value that again is just boosting everything. So we just want this to be fairly subtle, which it does not look like from there, but it will be once you're actually going through your opacity. So that's how we're setting up the color. It's just one color. It's just a dark, kind of a dark gray, and we'll change that in our material instance. And then our mask, before we go into kind of the rest of this, we have a mask that we're going through. We're setting it up with a generated band. This is kind of similar to what we did before. Here I do not have it. I set this up as a parameter so that I can switch the direction if I wanted it to go left to right instead of up and down. And then I have this mask wipe parameter, which is actually just shifting the direction of our band on one of them. So it's just going to shift it on this one. Though there's a mask offset on both of them, this mask wipe will actually transition between the two. And that's why I have them multiplied together. So one of them kind of acts as a mask for the other. And then the power is to overall kind of soften the edges from in the Y direction. So I'm going to send that into a multiply with our chromatic intensity. So our mask will mask out our chromatic intensity. And that will ultimately go in through our opacity. And then I'm doing a second power shift to kind of give more of that energy band, just accentuate it a little bit more and create a lot more fall off in the Y direction. And I am adding that to our chromatic intensity as well, which I'm going to send into our refraction, because we're going to use that to kind of determine some of our refraction values. So before we go into refraction, I'm going to go into our refraction normal. Again, same system multiplied by our time multiplier and texture. And we're going to send it into a normal from height map, which will give us a normal map, and it'll give us intensity that we can play with. So this will help determine how intense our normals are on our refraction values. And then I send it through. So if you have a normal map and you wanted to use that instead of this, you wouldn't use the normal from height map, but you could also send your normal map through a flattened normal. And that way you can control the normal intensity through your normal flatness amount. So I've done both just because I like to have a little bit extra control, and it kind of gives different looks to things. So I've sent it through a flattened normal, and then I'm just sending that through a lerp, the alpha being the mask and the value where I don't want this normal to be exposed, setting that to 0. And then here is the B value is our actual normal, and we're just sending that straight into the normal channel. Now this will activate after you do your refraction, so the normal will only be there if you choose to have an input in the refraction, which we are just sending our lerp from 1 to 1.05, and we have a refraction amount that is being multiplied to control our alpha, and the alpha being, again, this mask that we have, and that's controlling where our refraction will be seen in that mask. Then we have our world position offset, and this is a little more important here. I know we didn't do this whole setup off the back end, we just had this front end setup, but I have a noise texture that's going to control where our world position offset scrolls over our mesh. And again, similar setup that we've had before, just running it into a mask, so it's just giving the white value. And this is really not important. You could have just done the red value again. This is in case I change this to a texture that's packed. So if I wanted to do a packed texture, I could do this, and I could convert this to a parameter too, so you can choose your channels along the way. So some things are just a little arbitrary just because there's extra functionality needs that I may have in the future. And so I've just set them up that way. And then there's our world position offset amount, which I'm just defaulting to 0. All right, final things, erosion. See, we are actually using the alpha version of the smooth step this time. Same thing that we set up before with our erosion, setting it into a depth fade with a default of 25. And then we have our warp mask again. This is also going to determine that direction that we're going to warp this or move the energy in the direction of the energy shield from bottom to top. So same mask that we used before, all multiplied together and feeding into our opacity. And that is the shader for our distortion. All right, so let's quickly go through this particle material. This is basically a carbon copy of the energy base material. The only things I've removed the color, I removed the radar scan, and I kind of shifted up the warp energy as well. The other difference is I added in a particle color from the Fresnel mask, so that's being multiplied for the color, and the opacity is being multiplied by our opacity mask and our warp energy. Those are put in, and I'm just multiplying that into the opacity so that we can have full control from our particle systems. And then I have some dynamic parameters set up. So for the warp energy, we're going to use that to drive this warp energy mask. And then there's another one set up down below for the radial beam. And we're using that in our power. So that's the beam mask power. And running the other one through the world position offset. And that's going to be our world position offset amount. And again, I gave this a static switch parameter so that I can use it as a particle system, or I can use it just to define it through the material itself. What's going to happen is these particles are going to be used in one of our systems as kind of like a projector to simulate activation of the energy shield. And so I'm just needing to get kind of a cool look to the particles themselves, but having these white values at the top will allow us to really push those vertices out in an extreme way. And that's why we're using the dynamic parameter, because we're going to be able to control that world position offset amount on those specific particles and really push the vertices where those one values are. So we kind of get that projector-like look. In our material instances, we'll start off with the dome. In the examples or in the master project, you'll see 2. I'm going to use dome 2. I just had different variations going on, I think, with the grid lines. Just make sure this is real time here so you can see it. So the values I changed here are the warp energy and the erosion. And then the grid, I wanted kind of more of a separated kind of scrolling energy look. And so my grid settings, this is kind of how I did that. I just went negative in the noise power. My grid size, I made a little bit stronger, a little bit bigger. And then the grid width set to that. And then as far as my noise, I just increased the scale, changed the speed. And then the last thing I did was just added a little less to the world position offset amount. And that was just purely an aesthetics choice. For the floor, you can see how that's working. And the only thing, don't even think I changed the fade distance. That's there. So our floor is just kind of how we have it set up in that base material. Very fine grid on this one. I didn't mess with the grid size. I left it as is. So there's just a very, very slight grid. All right, and then the dome distortion. So as I noted before with the color parameter, so I changed the color and the emissive intensity so that I got this kind of orange banding energy. I kind of drove the emission more from the color than I did from the emissive intensity. So I kind of lessened that a little bit and changed some of our chromatic energy settings just so that the blending of that RGB shift with this orange wouldn't compete. I just wanted a very, very subtle kind of chromatic shift there. You can see some of the other settings I changed in the distortion and the erosion, as well as the refraction amount. And that is basically it for our material instance for the dome distortion. As far as the particles go, nothing really changed there other than me just turning on the world position offset for particle use. Okay, let's move into our particle systems. I'm just going to show you these quickly here. So I created an emitter, which is just based off of a fountain emitter. So if you go to Effects, Niagara Emitter, New Emitter, I just came down and chose the fountain emitter and then just changed a few things. So I left most things the same here. The spawn rate, all of that. The only thing I really changed was the sphere location. The sphere radius is 150. And then I also changed this from sprite renderer to a mesh renderer, and then just selected our mesh for our particles. So just our particle mesh, selected that and threw that in there, and then selected the override materials, and selected our material instance for our particles. And that was about all I set up. And then threw that emitter into our particle system. So if you come out here, you can just create a Niagara system. You can create it from your emitter. So that's how I got this first emitter, and just renamed it to our radial energy activation. And this is blue. So you can see when this kicks off, these are our blue particles, and that's just when the shield activates. So I did change these to GPU, so they're a little less intensive, and gave it a fixed bounds radius of -1,000 and +1,000 in the max. I did add a little bit of a loop delay to it, just so there was a little time overlap. And then my spawn burst, I added a spawn burst to this, which is set at 50. My initialized particle. Here are the settings for lifetime, which I believe I just left alone. You can see the sphere location is there, except the only thing I changed in that is I activated the hemisphere Z so that it didn't spawn on the Z axis, and then I used the surface only band thickness and gave it a value of somewhere around 0.136. So those are my settings for that. Then just in the add velocity, I give it a velocity with a random range vector. So just you can choose your drop down, type in range, and I'll give you a random range vector here. And in that, these are my minimum and my maximum values, around -350 and +350, with a slight minimum value of 50, just so there's some variation there in how much they spawn vertically. And then going through my drag, I like to animate the drag, especially for this. I gave it a drag of around 5 to start. And then as they kick out, they kind of come to a halt. And so I animated with a curve. So when my drag, I just chose float from curve, and then a curve for floats, and gave it a value of 13. See, actually, sorry, my value's at 15 there. So it goes from 5 to 15. You can just set these. This is an auto keyframe, so just make sure they're set to auto. It kind of ramps it up and kind of fades it off there at the end. And then for my color, I used a scale color. I initially set this up to work from a linear RGB and then chose it to do a curve here. I won't need the curve for this one. I duplicated the system and used this elsewhere, but this just stays at one color. So the curve really isn't necessary. It's not used, but I used it later on. I was thinking about changing the color over time for these particles, set it at a fairly high value of 250. And these are my settings for that blue color. And then added a curl noise force, just for a little bit of variety. As they kind of float in, gives them a little bit more movement. So set that to 50 and 50, and then I panned the noise field in the Z direction. And you've already seen the mesh renderer, I didn't really change. That is all fairly the same. The only thing I did change here is the velocity. So for the facing mode, I changed that to velocity so that they would come out based on the velocity direction. And that's it for this first emitter. So these were our activation particles. In the second one, you can go through this same thing. It's GPU. And spawn burst is the same initialized particles. I gave a little bit different lifetime. My velocity is the same as I had before, and then I also added a velocity from point on this. And that's because I wanted it to come out from a point location. So you can see they all kind of come out in more of a spherical pattern just from that point. I gave it a very high minimum value, high maximum value, and no real direction or origin offset here. And then my drag is the same. It's just going from 5 to 15. Scale color is the same. Curl noise. And then I have a dynamic material parameter set up on this. And that was to just change the beam mask power and the warp energy mask. And then on the world position offset amount, this is what I was describing earlier, we're going to give it a pretty extreme WPO amount. These are all set in the 0 to 1 space. So I just did a linear curve that I just added points to. And you can kind of see each of those values. But it's just randomization. You can give these different values. You don't have to choose what I did, but they're very excited kind of curve values. So they're very sharp. And then they kind of trail off towards the end and kind of start, non-existent at the beginning. So as long as you just started at 0 and ended at 0, you can give it some nice peaks. And then my scale curve, I actually set to 4,500. So they had a very extreme boundary. So instead of trying to set this to 4,500 and play with the values there, I just wanted a 0 to 1 that would be controlled by the scale curve itself. So I just gave it a high value. So those really peak out. And you can just see how they're shooting out. And then finally, we come over to our persistent particles, which are these guys that stay afloat during the entire energy shield. And these will actually change color. So instead of doing a second emitter with a new color, it was more appropriate just to allow these to change color. And so everything is roughly the same here. There is no loop delay. Just make sure I didn't give one. Yeah, there's not one on the other system either. Spawn rate is at 25. And then lifetime was set back to what it was before. Very low sphere radius. So instead of coming out from a point, I just had it come out from the sphere radius and set the hemisphere to Z. No surface only band thickness here. And it's on the inside is my surface expansion mode for this one. Velocity was a little higher, more intense, because I wanted these to pop out in the Z direction pretty fast. And this time I did not animate the drag. So I just set the drag at 5. And that was enough to kind of keep them from moving any further. But I still wanted them to kind of float off just slightly instead of coming to a halt. And then my scale color, this is kind of the value I gave it. So again, made vector from linear R color RGB, scale linear curve. It's my blue value, which then goes into a very high value of 500. And then I'm going into kind of an orange color. And you can just steal these colors from the color palette. So you can just put these up here if you'd like to reuse them, which I love to do. And if I hadn't mentioned this already, you can also create new palettes, rename them, and you got a bunch of different color palettes you can pick from. And then at the end, I'm just going down to 0 on black. So they're just kind of disintegrating, and then the alpha curve is just fading them out completely. Then curl noise, the noise strength I upped, and I also changed the pan noise field to be 1 in the X direction. And I gave it a mesh rotational force on this one, just so they're rotating consistently, just from 0 to 1. So again, I just added a random range vector. And velocity, facing mode, same thing. So all the rest of the settings are the same. These two down here are carbon copies of these two up here. The O is for orange, and the B is for blue. So these are just inheriting that orange color. Nothing has really changed. So if I went to scale color, you'll see these just have the orange, this lower orange color, which is just set to a high value. And same for this one. So everything else is the same on those. So that is our particle system. Now let's move on to the blueprints. All right, so we're going to move through our blueprints now, and you can see in the project folder under blueprints, there are two examples. One is the completed energy shield. So if you get lost at any point, you can see all the functionality that we've built out or that we're going to build out. And then the first one is the actual one that you can work off of and build your own functionality out of. So it's just the energy shield portal without any of the additional functionality. So I'm going to go ahead and work from the one that I've already set up everything so you can see what I've done. The very first thing I did with the event begin play. So this I'm not going to talk about because this is me setting up the 3D function or the functionality for the 3D asset, which is not part of this tutorial. So I'm going to ignore this, and you'll already have a timeline that activates it as well as the events. But I will show you how I do all the rest of it because that's usually what you would do as an effects artist to build this out. So most of the time, if I'm building out an effects system, I'm using this kind of logic to do a proof of concept. And I am just setting up the logic to show kind of a designer how I want it to go, and then they'll take it and make it even prettier. And sometimes they use what I do, but most of the time they have way better systems to handle all this. So in order to get your inputs so that we can use these keys, so if I were to just type in P key and scroll up, you can see we have access to all of these key bindings here. Now these would usually be in your inputs section under your settings, and you can define them in your action mappings and things like that. But if you're working on a game that's in production, those will already be defined and you don't want to mess with them. So in order to access them in a blueprint and use them properly to control the function or the event you want to set off, you just enable the input. So grab an enable input node and then just get the player controller and hook that up. And that will allow us to use these as the player controller when we play this blueprint. Now you wouldn't want to implement that in the game because that would override your action mappings and things would get crazy. So this is more for just doing or setting up your events that way. So next what I'm going to do is I'm going to add in all of my meshes, and we just grab our meshes. So you're going to go in here and just grab a mesh and just add that component. And you can see my scales here. I set this to 2 for the dome. So the dome is at 2, and a location I bumped up just a little bit. The floor is a little bit bigger because that's going to cover kind of the area where I do my energy distortion dome. And that is just over 2, set at 0. And then I have my dome distortion, which is just a little larger, and that is so that it sits outside of that main energy dome right there. And again, that's at 0. And I've just set all these to movable so that you don't have to bake lighting, and the lighting can change dynamically with each of these meshes. And then I have also added in point lights. So you just drag a point light in, and I'm using this for the energy. So energy will come off the bottom portion here through this energy light, which is energy light 1. And I've set it to a blue color, just a regular value of 1, because we'll change that through the intensity. And then I've given it these settings for the radius. And I also turned off cast shadows. I do not want this to cast shadows. I just want it to cast light. So I initially played with the intensity to get the intensity where I wanted, which I believe was around 11,000. And then I turned it off so this light is not on when we start the game. It is going to turn on through our blueprint logic. And then the second light is up top because once this energy shield activates, there will be a blue glow, and that will play on top of our character. And again, the settings are fairly similar, just with a little bit change, same blue color. And we're going to activate these from our blueprint. So going to our logic, those are the only things we need. We also need our particle system. So again, just click on that, add that component to this arrow here, this arrow component. And we're going to turn off auto activate because we're going to use the blueprint logic to activate it from our controls. So the first thing we want to do is we want to set up our scalar parameters on our meshes. So you just drag these in, and then you just drag off and just hit set scalar parameter value on materials. And since we only have one material, we really don't have to define this. So this is just going to set our parameter name that we have. So we're going to type in our warp energy because we want to control how this activates. And if you remember, our warp energy was driven by a power that allows us to kind of erode away the value. So that's going to basically allow our shield to kind of activate or look like it's activating on. So we need that. We have an erosion parameter here. We're using the same one for the dome and the floor. I'm using a separate warp energy, and you can see these values that I'm setting up. These are the base values of where they're going to start when we play an editor here. I'm using the same warp energy for the floor and the distortion dome. And then I'm using a different erosion value for our distortion. And then our refraction amount, of course, only relates to our distortion dome. So I've set up all those parameters. And now we're going to use our timeline to activate those. So this is our actual energy portal. And these are all of our energy settings, or our dome settings, and our floor settings. So what you can do, like I said, you can go ahead and find your keys, and we're going to use these to kind of debug our activation. So when we play an editor, we can hit a P key or an O key, and we'll activate and deactivate respectively. But we want to do our event begin overlap. And that is the one thing I did forget to show. There is a collision sphere here. So if you type in collision, you see our sphere collision. We added that. And you can see my settings. I just have it at a radius of 6.56. Or sorry, the sphere radius is around 8.77 and the scale is at 6.56. And I wanted it to stay kind of small because if you were to do it to the size of the dome, when the character leaves the dome, he kind of crosses through it. And then same for when he kicks it up. So I wanted to make sure the character, when they come into the middle, it activates. And then as soon as they step off, it deactivates. So it looks like it deactivates before they step through it, which was a little nicer looking. So that's why I have a smaller target here on the event begin overlap on the collision sphere. So we're going to choose event begin overlap because that's going to detect our collision and allow us to activate our particles. You just drag in your particle system here, and we're going to set that to activate. So just drag off and type in activate. And then we're going to run it through a small delay of 0.45 before we actually kick off this timeline. And here's what our timeline looks like inside. We have the energy floor, we have our erosion distortion, and then our refraction, our energy shield, and the erosion on our shield. And then we have a light intensity. And don't mind this bottom one, that is the one that should already be set up for the generator itself. But here's our light intensity. And if we look at our values for our energy floor, we are starting at a time just off shifted from 0 and going to 25. And then our value is at minus 1.75, since that was kind of the energy, the warp energy value that we gave it, where we want it to land. And then if we look at our erosion distortion, we started at 15 here at 0.5 on the timeline, and then going to 1 second with a value of 0.8. Remember, this is all of our activation settings. So when the shield activates, this is what will play to bring it to life. So then our refraction, we start at 0, and I'm just going to start at 0.5 because I want the refraction to come in just slightly later than our energy does, our energy shield does. And we're going to go just to 1 second, so it's going to be a half a second transition at the value of 5 for our refraction. And then we will go from 85 on our energy shield. Again, this is our warp energy for our shield, and it's going to go down to that value of minus 1.75 that we had previously defined. So from 0 seconds to 1 second is how long that transition will be. And then we have 0 on the time and 20 for our erosion on our shield. Value at 8.95. So 20 to 0.85 on the time and 8.95. And these are all things that I kind of, played around with initially before, just so I could see, how they were working. So there's some trial and error involved in this. This is 0 for our light intensity, and it's going to go up to 1. And the reason why this goes up to 1 is because we're going to multiply it by a float. So if you come down here, instead of trying to do 11,000 on our timeline, it's easier if we just do a float times float. And we define the initial value, which is 0 to 1, and that will raise our intensity from 0 all the way to 11,000 by multiplying it times that value. And of course, you can see our energy light is there. So that's our first light, which is the one on the ground. And then we're going to give a delay of 1 second so that the energy shield has time to kick on. And by the time it reaches the top and kind of casts light onto the character, that one will pop on. Now we're showing that the energy will already be there. So that 11,000 value will already be on this light. So it'll almost pop on, which is fine for how the energy shield kind of comes into existence. Then all of our values that we've set in our timeline, we're going to run in respectively to our scalar parameters. So we can set those on the material. So you can see our energy floor is for our floor. We have another value here, our energy shield, which is our warp energy for the dome and the distortion. And then we have an erosion, which is also going from our floor and our dome. And our dome distortion is running into this warp energy parameter, erosion, and the final one, the refraction. And you can see they all connect respectively. So there's our refraction. Here's our erosion for our distortion. Here's our erosion for our shield, for our dome basically. And then here's the energy shield for warp energy. So you can see those are all running into those values. So when we step into the energy generator, that is going to kick it off from the start. So you want to connect it to play from start. So it starts the same every time. And same thing, you can press P so that you can look at it from a distance and kind of see how it's working. And then we're going to do our event end overlap, and we're going to run it into a sequence. And this is so that we can kick off multiple different events without trying to run everything through loops and all this other stuff. So we're just going to, the first part of the sequence is going to reverse it from the end, which means it's going to send it all backwards. Now, initially, I thought I was going to need more time, and so I had set up a 5-second timeline. And so if you want to have more time, you can. However, it will start from the end of that 5 seconds and reverse it from the end. So I needed to set a new time so that it was quicker when you step out. So I set it to 1 second, which condenses the timeline down to 1 second. So it just reverses everything for 1 second, and that will deactivate it a lot faster. I did that as kind of the last input. It didn't matter here what the order was, because the second thing I wanted to do was deactivate the particles. So you just run out of here, type in deactivate, and we're going to deactivate our particle system once we step out of the generator. And then just compile it and save it, and we will put that into our level. And then you can see, so we've got it in our level here. And when we hit play, we can step inside of it, step out of it, and it kicks off, and we can hit that P key to kick it on and hit that O key to kick it off. And so it's working as intended. So I hope you enjoyed this tutorial. Thank you for sticking with me till the end. And I hope that you are able to create some pretty awesome looking energy shields. Thanks so much.